Hello there, I'm Thomas Hatsios, the British-American pilot flying the Boeing 777-300ER international flight from Zurich International Airport back to Zurich International Airport. Right now I'm in the cockpit for the pre-takeoff preparation of the Boeing 777-300ERX of the PMDG simulation and Microsoft Flight Simulator X. So I'm gonna start showing you the instruments and the displays inside the cockpit of the Boeing 777-300ER airplane. So I'm gonna start with the primary flight display. The primary flight display that displays the airspeed indicated, the airspeed selected from the autopilot and flight director system panel, the ground speed, the barometric altitude above the sea level, the barometric pressure of the outside atmosphere, the target altitude selected from the autopilot and flight director system panel. You can see here the primary flight display with the flight mode annunciator, the navigation display, the autopilot and flight director system panel, the upper and the lower ACAS, the thrust levers, the overhead panel with the electrical, the hydraulic, uh, the fuel system, the electronic engine control for the engines, and the pressurizer. So this is some of the systems, also the flight controls you can see here. So the primary flight display also displays, as I told you, the airspeed indicated, the airspeed selected, the barometric altitude above the sea level, and the altitude selected, the radio altitude above the ground level, the rate of climb and descent of the aircraft in tens, hundreds, and thousands of feet per minute, the magnetic heading and track. We have the magnetic north pole and the true north pole, and the magnetic variation depending on where we are in the world. We have the pitch ladder in degrees and the flight director of the aircraft, the flight director crossbars and the autopilot crossbars for manual automatic guidance of the aircraft. Also the Lszh localizer and the pitch ladder in degrees and the bang angle in degrees of the aircraft. And also we have the angle of attack of the aircraft as a size, and the flight mode annunciator with the autopilot and the flight director, the autopilot and the auto throttle navigation modes and lateral and vertical navigation modes. So we have also the autopilot flight director system panel. We have the navigation display that displays the airports, the waypoints, the nav aids, the voice stations, the GPS position, the inertial reference position of the aircraft. We have the terrain weather display. We have the weather radar with the terrain reflections also with red, green, and yellow. We can see some airports here, and we can select the distance in nautical miles. And also we have the magnetic heading and track again, the magnetic north pole and the true north pole, and the magnetic variation. We have the wind speed and vector, the direction of the wind, the next waypoint within the overflying, and also the ground speed. And the RNP and the NP, the required navigation performance, and the GPS position of the aircraft. After that we have the autopilot and flight director system panel. The autopilot and flight director system panel that contains the autopilot and gates and disengage switches, the flight director and gates and disengage switches, and also the auto throttle left and auto throttle right and gates and disengage switches. We have the heading. We have the airspeed select node for the airspeed guidance of the aircraft in knots or in Mach, depending on the altitude flight level that we fly. So we have also the modes for the airspeed guidance, like the flight level change hold switch. We have the AT, the auto throttle hold switch, and also the climb continuous switch. So we have fixed thrust, like maximum continuous fixed thrust for glide or idle thrust for descent, which is fixed thrust mode for the auto throttle, and we have also variable thrust like the cruise and the approach for the approach and landing of the aircraft. So the autopilot and the flight director will determine the auto throttle modes we're gonna fly as we climb or descend and cruise or approach for landing. So we have also the VNAV and the LNAV, the lateral navigation and the vertical navigation of the airplane. We set up these modes using the flight management computer. We also have also have the we have the bank angle limit select knob. We have the heading hold select knob and the heading hold switch, and also the vertical rate of climb and descent of the aircraft in tens, hundreds, and thousands of feet per minute, or in a flight path angle. We're gonna make it flight path angle and the hold switch for this mode. We also have the altitude select knob and the altitude hold switch, and the VOR localizer hold switch, and the approach hold switch for the autopilot flight director system panel. We also have, as I told you, the primary flight display. We have also the thrust levers. We use the thrust levers to activate the thrust the engines produce. I'm gonna show you later. I'm gonna make an engine start demonstration. I'm gonna show you also the upper and the lower ACAS, the indication and alert system display, and the multi-function display of the aircraft. The flight management computers. We're gonna set up a route. The aircraft is gonna follow, or we're gonna follow it manually, or the autopilot flight director is gonna follow the flight plan in the later on vertical navigation. We're gonna select a departure and arrival airport, departure and destination, and the intermediate waypoints will be overflying, and the departure and arrival runways. Maybe we're gonna select an Lszh localizer landing, like I'm gonna show you later. Also, I'm gonna show you the flight controls of the aircraft, the flaps, the slats, the horizontal tail stabilizer trim, the transponder that displays other aircraft in our navigation display. Also the weather radar, the terrain radar, and other systems. Like in the overhead panel, we have the IDGs, the integrated drive generators, left and right engine electrical system generators for alternate current. We have the batteries, the APU generator. We're gonna use the APU for starting the engines. We have the ADIRU, the air dynamics reference unit, and the flight control computers, the thrust altimeter compensator, the hydraulic pumps, left and right engine, and the electrical backup with the pressurizer function. I'm gonna show you also the electronic engine control for the engines, the fuel system, the left and the right wing, and the center tank of the aircraft, the fuel container, and the forward and the aft pumps, and the crossfeed, and the low and the high pressure fuel valves for the left and the right engine. Also the wing and engine ADI system, the cabin pressurization, and the bleed air system with the pressurizer from the engines we use for cabin pressurization, wing and engine ADI, hydraulic fluid C1 and C2 pressurization, air conditioning and ventilation, and also we use the APU compressor for starting the engine to the ground. So I'm gonna start showing you all these things. Thank you one more time for watching me. I'm Thomas, Hatsios, the British American pilot flying the Boeing 777-300ER into night flight. So I'm gonna start now. I'll show you inside the cockpit, the instruments. So we have about an hour for this flight. So you can see here we have, as I told you, the general view of the cockpit and the outside view of the airplane of the Boeing 777. So you can see here we have the flight control yoke of the Boeing 777. We control the ailerons and the spoilers like this, the elevator, the horizontal elevator, and here's the vertical stabilizer, the rudder in the rudder pedals. So here you can see the primary flight display. You can see the minimum airspeed displayed right now, 30 knots. The airspeed selected from the autopilot flight director's panel, displayed with purple, and the barometric altitude above the sea level, also 1,430 feet. The ground speed is 0. The altitude selected from the autopilot and flight director system panel over here. You can see the airspeed and the altitude, the heading, the vertical rate of climb and descent. I'm gonna talk to you about later. So we have also Here is the rate of climb and descent of the aircraft. This needle will determine how fast we climb and descend. The flight director and the autopilot crossbars here with the pitch ladder in decrease and the bank angle in decrease. Also the takeoff go around, which is right now. We have the magnetic heading and track of the aircraft. Magnetic North Pole and True North Pole. The heading is selected 360. And this is the radio altitude of the aircraft 2 feet above the ground level. So this is the flight mode demonstrator. I told you the HSI, the horizontal situation indicator, and the altitude indicator. So we have the angle of attack of the aircraft here also. All this data has been provided, like the GPS information. Over here we use this switch in the overhead panel in the ADIRU, the Air Data Inertia reference unit. I'm gonna show you now in the other view of the overhead panel, also the navigation display. So I'll have to come here in this view of the cockpit. So you're gonna see also this view. So I'm gonna come here in the overhead panel, and so you will have here you can see the ADIRU Air Data Inertia reference unit, Air Data computer, and IRS inertial reference system. So this we also have the primary flight control computers here, the thrust asymmetry compensator, the electrical system for the left and the right engines. So all this display the airspeed, the barometric altitude, the radio altitude, the barometric pressure, the magnetic heading and track, also the GPS position, the inertial reference position, and the attitude of the aircraft in terms of gyroscopic acceleration. The acceleration is being provided by this small switch, the ADIRU, the Air Data Inertial reference unit over here. So if we turn off this switch, we're gonna have to realign our position, our inertial reference position. So maybe we're gonna do that later. I will continue with the navigation display now. Later come the autopilot and flight director system panel. So you can see here we have terrain level displayed with green, yellow, and red. With green, yellow, and red. You can see the red is 6,100 feet maximum, 061. 0 feet is the green. We have also the sea, the lakes, the rivers. So maybe if I increase the distance, maybe we're gonna see some sea coming on from sour. Maybe if we change the direction of the aircraft, we're gonna see the sea. So right here we have this display. You can see the airports. This area here is so this is all the airports loaded now. This area here is the Switzerland. The Swiss Alps. You can see the terrain level. This area is the France. This is Germany. You're gonna see later the route the aircraft is gonna follow. This is the position of the aircraft symbol. We also have the required navigation performance, the acquired navigation performance, and the GPS positioning from the ADIRU. So you can see this distance 160, 320 nautical miles. Here is the heading 326 magnetic. You can use also the track. So you can see the terrain here from the weather radar display reflections, and also you can see other aircraft using a transporter here. The switches here. This I'm gonna maybe explain it later. So you will see we're gonna have the warning of another aircraft incoming, and maybe we're gonna have an aircraft here displayed as it closes into our own aircraft. So we're gonna have it like in a radar. So I'm gonna show you now the rest of the systems. We also have, I told you, the route. We're gonna create a route using the flight management computer here. This inputs from this computer that totally can control almost the whole flight. the flight path, the climb, the cruiser, descent, the approach, landing. We can use even auto land. So I'm gonna come to the autopilot and flight director system panel section. We have about an hour left for this flight, so it's not too much time. So you can see the auto throttle here. You can see the message here coming on if we disconnect one of these. So we have the flight director, also the flight level change here. This switch, this is the airspeed select or Mach in knots, or Mach if we fly higher. So we can just select this. We have to reset this if we turn off the flight director. So this is the press roll. Also we can use the AT, the climb continues. So we can see some modes: the LNAV, the VNAV, the autopilot disengage. If we engage the autopilot, we have also heading track. We can select like the bang angle limit of the aircraft. This is also the press roll. You can select this. We select like this. So I'm gonna use this heading like 136 degrees. We can just select, as I told you. We can use also the altitude here, 35,000. You can select the hold again like this. This will be select idle mode. You can use only one mode at a time. Altitude or flight level change, and also use the thousands or use the hundreds. We have the heading and track here. We also have the flight path angle in degrees. So if I'm gonna use that, you will see the flight level change here displayed. Flight level change speed with the heading hold right now. So we can set up a few more modes. We can set like with the flight director on, we can set the altitude instead. So we're gonna have the altitude now, the heading hold. You can also set this mode here. This is a vertical speed flight path angle. You can set a flight path angle in degrees for like for descent or for climb, using this slider here. So we're gonna have the flight path angle now. FPA. Maybe if we set the autopilot, we're gonna see that better. You can see the markings here. The FPA flight path angle, flight director. This is how much we have to climb the aircraft here, the cruise altitude. So on the 3.5 degrees flight path angle. So you can use the vertical rate of climb and descent, and the other mode. This is hundreds and thousands of feet per minute for climb and descent. You can do that manually or automatically using the autopilot. I'm gonna show you later in a couple of minutes. So we have 25,300 to 53 the airspeed, heading 136 displayed with Matsera, and also we have the flight director with the crossbars. You can see here we have to climb here 3,500 feet per minute over here, this setting. So you will see the tick marks in the display. We have a couple more things also to show you. So flight level change, we can use the autopilot on. We can use also here, we have the VOR localizer and the approach for the auto run. So this also hold. You can use either one. Flight level change or altitude. So we have the autopilot now engaged with the flight level change speed. You can see the AT here. This will determine how fast the aircraft will climb and the airspeed is gonna have, and the heading. So you can use the altitude. Again, you see with the autopilot engaged. And one more time we can disconnect the autopilot. You can reconnect it again. So if I press this, you'll see the warning, and we have here the autopilot disconnect here with red. So we can cancel this warning. We have to reset this, reconnect the autopilot. You can see the autopilot is connected again, and we can disconnect it by moving this yoke by pressing this small button here, this switch. So this disconnects the autopilot again. You will see the warning one more time, autopilot disconnect. So we cancel, reconnect. So we don't need the autopilot right now. We're gonna come to the rest of the systems like the side controls and the thrust levers, maybe the overhead panel. We have a few more minutes left to go. I'm gonna show you as many things as I can about this flight. And then make a small flight about. So I will come here, a couple more things. I want to explain maybe better, but we have a lot less time now. So you can use the thrust levers to activate the thrust. The thrust levers will give a signal here to the FADEX, the full authority electronic control computer, some warnings here. You can see here we have the N1, which is the low speed, low pressure compressor phase of the turbofan turbocharged engine. The exhaust gas temperature per engine, left engine, right engine, 104.6% is the maximum rated thrust rotation speed of the fan stage of the low pressure. So I'm gonna talk later about that. The duct pressure, the outflow pressure from the engines will increase the thrust. Also the duct pressure increase. The N2 also. The high speed, high pressure compressor stage of the engine, the fuel flow per engine per hour, the oil pressure, oil temperature, oil quality, and the vibration of the N2 stage of the engine. You can see how can I activate the thrust like this. So I can use also here I have this the auto throttle disconnect switch here. As you can see, the takeoff go around switch, the thrust reverse, the fuel flow per engine here, left and right engine, the fuel control. A couple more things here around the engine, but not related to that. It's the flap settings here. You can set the flaps. It's in the same quadrant as the engine. You can set the speed brakes up and down. Also, sometimes have been activated by the engine function. So if I use the thrust reverse like that, you will see the reverse, and the speed brakes are extended automatically as we give you a signal to open the blocker doors and also extend the speed brakes for slowing down the aircraft. As you can see, so here we have it. We can retract this. You can deploy again. So this is retract, this is redeploying. Also the other side, the front side of the fan here, you can see. And also deploy again the thrust reverse from the front fan. So this is so much for the thrust reverse. I will show you now a couple more things. I will talk to you about the engines. You can see we have some other displays here like the Flught. So if I move the thrust lever forward, it will also retract the speed brakes automatically. So We'll talk to you now about the thrust levers. So when you move the thrust levers, you activate the thrust. You give a signal to the FAREC, the full authority digital electronic control computers. One installed per engine, dual channel, redundancy. If one channel fails, the other takes over. Controls and monitors all the displays that be related to the engine functions, like the N1, which is the low speed, low pressure compression stage of the turbofan turbojet engine. The N1, we have the low speed, low pressure compressor and turbine, the exhaust gas temperature, and also soft. The exhaust gas temperature per engine, the N2, which is the high-speed, high-pressure compression stage of the turbofan turbojet engine, and the high-speed shaft of the turbofan turbojet engine. We have the G90 or RB11 usually with the simulation. So we have also the fuel flow per engine per hour. We have the oil quantity, oil temperature, oil pressure, and the vibration of the N2 stage of the engine. We have also the FAREC's regulator and control, the thrust, and also the engine start, engine shutdown, the fuel flow. It monitors and controls and optimizes the fuel consumption of the aircraft as it flies into higher or lower altitudes. Also by changing the pressure inside the engine by opening and closing the 5th and the 9th stage of the outflow valve. If we have an overpressure, for instance, inside the engine, we will open the outflow valves to relieve the overpressure. If we have an underpressure inside the engine stage, it can close the outflow valve to increase the pressure. Also, this regulates as we climb into higher altitudes, lower pressure. We're gonna need different fuel and air mixture rates and other things. So these are some of the things the FARECs can do. So I'm gonna talk to you now a little bit about the aircraft takeoff and flight, the flight theory of the aircraft, and show you the flight controls. We have like a few more minutes for this flight. So we use the thrust levers to increase the thrust to make the aircraft move forward. We can do only forward movement, propulsion using the turbofan engine. It's not like the fighter can fly vertically. So we move forward. I'm gonna use now the Newton's first, second, and third law of kinematics of physics, and also the Bernoulli theory and some aerospace engineering, aeronautical engineering, physics, and mathematics to explain some things about the flight theory of the Boeing 777-300ER airplane and other aircraft. So we use the thrust from the engines for takeoff. We need to achieve an airspeed of about 154 to 270 kilometers an hour with this aircraft. Right now we have 254,000 kilograms of takeoff weight, which is below the maximum takeoff weight, about 533,000 pounds, from which 46,000 kilograms or 102,000 pounds is the fuel on board, which is 30% of the total fuel the aircraft can hold, which is below the maximum, and also way below the maximum. And also we have 30,000 kilograms of passenger and cargo, which is also below the maximum takeoff limit. So we have a total of 254,000 kilograms or 533,000 pounds. We need to achieve an airspeed with this weight and 15 degrees of flaps and 4 degrees and horizontal stabilizer trim. We need an airspeed of 154 knots or 270 kilometers an hour approximately. Just for takeoff, a little bit higher as we fly and then as we climb, or as we cruise and then come back for approach and landing, as we descend and approach for landing. Then we're gonna use different flap settings and altitude of the aircraft, so this is gonna need a different airspeed. So during the whole flight from the takeoff, we need to overcome the stall speed. The stall speed is an airspeed for the angle of attack of the airfoil of the aircraft is gonna stall. It's not gonna generate the lift force to hold the aircraft up into the air. to take off into the air and hold it up into the air. Climb, for instance. The lift force is equal to the weight of the aircraft, that is the mass times the acceleration of the Earth's gravity. Of the Earth's gravity. So we need to overcome the stall speed, as I told you, of the wings. The wings generate the lift, that is the force to overcome the weight of the aircraft. So they also hold the weight of the aircraft. I'm going to show you now this thing, the outside view, and talk to you about the flight theory. So you can see here we have the outside view of the Boeing 777. You can see the wings, the surface area of the wings. We can increase it using the flaps and the slats. They also hold the weight of the aircraft. You can divide the aircraft weight over the surface area of the wings. Also the wings generate the lift force that is going to make the aircraft flyable. They also used for changing the direction of the aircraft as it flies, having directional control, holding it stable in flight. Otherwise, so you can see here we have the mean aerodynamic chord. The 25% of the chord is the position of the center of gravity also of the aircraft, and the position of the maximum aerodynamic lift of the wing. This here, the 25% of the chord, and the position of the center of gravity. You can see the center of gravity of the aircraft forward and aft of this position by shifting passenger and cargo, and also you can see here we have the wings. So the wing surface, you can see, is more flat below the wing, and we also use the flaps and the slats to make something to happen. So you can see it's more flat as the airflow of the air mass, as the aircraft accelerates 270 kilometers an hour or 154 knots in the ground for takeoff. The airflow of the air is gonna generate an airstream above and below the wing. So below the wing have a flat surface. The airflow is gonna move slower below the wing, so we're gonna have higher pressure here, and also the airflow is gonna be moving in the curved top surface. It's gonna move faster, so it's gonna have another pressure, a lower pressure above the wing. So we have a lower airspeed below the wing of the airflow of the air mass, and higher airspeed and lower pressure above the wing. So this creates the differential pressure below and above the wing that is gonna bubble up the aircraft into the air. And as you can see, this airstream, we have also the vectors of the thrust from the engines, the left and the right engine, symmetrical. We also have the front, the intake of the engines, and the exhaust of the turbofan turbocharged engines. We also have the center of gravity, as I told you here, and we have the moment arm. Also some forces for directional control are the moment arms. So the moment arm or lever arm is times the distance from the center of gravity all the way back to the horizontal tail section or vertical tail section here, over the surface area of the elevator or the rudder or the ailerons and the spoilers, and the distance they have from the center of gravity. So times the surface area times the distance times the airflow of the air mass per second times the acceleration of gravity. So this gives the lever arm climb to pitch up and glide the aircraft or descend. So this makes the force from the Newton's physics and Bernoulli theory of fluids. So Newton's dynamics physics and Bernoulli theory and some other aerospace and aeronautical engineering. So you can control the aircraft in flight, make it turn left and right. So this is the flight controls principle, and the lift, and also you have the propulsion from the engine. So these are the three main things you need. So the weight of the aircraft here, the center of gravity, is going to be overcome by the lift force from the wings, and the drag from the skin friction is going to be overcome by the thrust from the engine, the four forces of flight. So we have about a few more minutes. So I'm gonna show you now inside. You can see we have the flight controls, the yoke of the Boeing 777, the rudder pedals. This is for having directional control in flight. So I'm gonna show you how to control the aircraft using the flight controls, the yoke of the Boeing 777-300 airplane. So I'm gonna show you also what I use here for this simulation. In my computer, so I use the side stick to give the input, the necessary input in flight, to have the desired flight control, directional control, or attitude for flying the aircraft. So you can see here we have this side stick, the Lszh Extreme 3D. As you can see, I'm using to input the control of the aircraft, of the flight controls here, of the control column and the control wheel. So I control the elevator up and down, climb, descend, control the ailerons, so the spoilers turn left and turn right, and also the rudder pedals here, right for the vertical stabilizer here. We also have the tiller here for the nose wheel steering of the nose wheel of the aircraft in the ground, and the other side here. So you can see this is proportional movement as I move the side stick around. You can use it also for the Boeing and the Airbus as well. You can hold neutral. You have the horizontal tail stabilizer trim, the thrust levers. So also now the outside view of the same principle of the flight controls. So we have less time now for this flight, so I have to be a little bit fast. And I'll show you the exterior view of the aircraft and talk to you about this principle of the flight controls and the side stick or yoke control. So you can see we have again this side stick. I can move up and down. I have proportional control input using the computer method. So I can climb, I can descend, I can bunker left and right, and also the rudder pedals, yoke, the thrust levers, the horizontal tail stabilizer, the flaps and slats. So this is maybe you have a better view here. Yeah, like this of what I'm doing in flight. So you can climb, you can descend like this. Maybe it takes a couple of seconds for the control to activate, like the elevator. 1 second for the rudder, maybe for the hydraulic control fluid to move the surface. So I will show you now inside the rest of the things we need to do. So now I will show you the overhead panel and the multifunction display, the upper and the lower ACAS, the system display like the electrical and the hydraulic. So I'll come the overhead panel. I will show you the left and the right engine. Integrate drive generators. We have one installed per engine. 120 to 200 volts, 400 Hz frequency, constant frequency of alternate and current. 120,000 kilovolts is left and right engine. 25,000 kilovolts the backup left and right generators, and also the APU another 180,000 kilovolts, so 120 to 200 volts range of 400 Hz frequency alternate current. We can transform this current using transformer rectifiers into direct current. You can use also the battery current, which is direct current 20 volts for 2 hours, and converted into alternate using the static converter. So this is the overhead panel. So when the left and the right engine work and produce thrust to move the aircraft forward, we also produce alternate current using the torque rotation by moving in the gearbox of the engines, the IDGs, the integrated drive generators. They also compress the hydraulic fluid pumps and also provide some bleed air, some compressed air for the cabin pressurization system, the wing and engine ABI, the air conditioning regulation, and also hydraulic fluid, the C1 and C2 as I told you, and we also use the APU compressor for starting the engines in the ground. So I'm gonna show you these things. In the overhead panel we have like 30 more minutes for this flight, so I'll come here so you can see the overhead panel, the main overview. So again we have this view as you can see. You can see also the autopilot from this side, a better view of the aircraft. And the FS panel here, the displays, maybe a more flat view is more clear for my phone, camera phone to record. So you see the speed brakes, you can see the thrust levers, you see the thrust over here, you can move the thrust levers back. Also maybe we're gonna fix the flaps now to the 15 degrees for takeoff. So this is gonna make this display here to 15 degrees. We have the outflow air also. So this is the landing gear, the alternate gear. This is here the parking brakes. I'll show you later. The auto brakes. The parking brakes is here. This is the horizontal tail stabilizer trim. I will show you later. The fuel control for the left and the right engine, the fire extinguishers. This is the pit stream, the fire management computer. So this is the main principle. Here's the overhead panel. I told you the left and the right engine integrated drive generators, and the APU, the battery, APU battery, the left and the right engine drive, and the backup generators. I will show you if we turn off the primary flight control computer, the thrust assembly, compensator here. You can turn on off. I'll leave in the auto. I told you how to start the APU like this. We have the passenger oxygen here, some window heat, some hydraulic pumps. We have like you can turn on and off. So we have like 13 more minutes. So if I turn off, you will see the fault here coming on. Here I'm gonna lose some systems from the hydraulics. So you will see the warnings, pin generator. So we're gonna start losing many systems. Hydraulic pressure, spoilers. So it keeps going down, letting out this. So we need to reactivate this. Turn on. And back to the auto when it comes. So this is for the hydraulic left and right engine. Here is some lighting inside and outside the windshield wipers. But also the left and the right engine. I will show you here is the electronic engine control for the engines. So the cargo fire and the APU fire. We can use the start electronic engine control. I control the fire is normal and alternate, the auto start on and off of the engine. We can dump some fuel here if we arm this. This is the fuel tanks, the X-speed valves, left wing, right wing, and center tanks. I'm gonna show you in the systems display later. It's empty, so it shows this fold. The pressure with yellow. We can also turn on and off the other pumps. So here is the wing and engine on the iPhone auto and off. You can see the lighting here. So this is the left and the right engine, the pressurizer here section. so we can turn on and off. We need the compressor for the air conditioning, for the hydraulic fluid C1 and C2. You can see the air here. It displays air, so it needs a pressurizer at the RDIs. So we can turn on and off the bleed air from the left and the right engine like this. The isolation valves and also the APU driver. The APU will use for starting the engine, and also the packs, left and right packs. So we'll see some systems now failing here also by closing these. We're gonna lose the cabin pressurization in a couple of seconds with that press. You can see how many systems fail. And here we have zero duct pressure, no pressurizer. So you can see the hydraulic bleed, isolation. So is some of the systems failing like this. I'm gonna restart all the systems. The APU. Also, this is the cabin pressurization here. Auto. You can climb, descend, or manual. Open and close the outflow valve. So we have a few more minutes for that. And select the landing altitude for turn on and off this. Also the electric drive. You will see the electric warning here in the apparatus, electric backup generator. This is the system failing. So if we have any, so we engage that. Maybe we're gonna use some lighting for starting. So this is the overview. You can see some also circuit breakers here in case we're gonna lose the system and some maintenance in the ground. So you can see the systems here also. So this is the general overview of the overhead panel. Now I'm gonna go in the multifunction display, CDU and multifunction display. So you can see here the Boeing 777 again on. It displays the status. You can see the APU now starting. You can start the engines. You can see the hydraulic fluid. You can see the checklist, the normal menu before start. What we need to do. Normal menu. Non-normal menu if we have a failure. This is the checklist. The navigation. The synoptics. So we have the doors of the aircraft for the Boeing 777 are closed. The cabin can be pressurized. The landing gear, you can see the pressure and the temperature of the brakes. We have the left and the right engine, I told you. With the great drive generator. You can see the electrical load and now the main voltage, the batteries and the charging. The APU also is on and off, and the external power if we have any. The hydraulic fluid, left engine, right engine, the air pressurized here. You can see the air pressure. This pumps from the bleed air. 3000 psi with system, left, right and electric backup. And here you can see the consumption of the hydraulic. The systems that use hydraulic pressure over here. So we have also the fuel system. Left wing, right wing, the center tank, the crossfield. You can see the low and high pressure fuel valves, the total fuel on board, and the left and right wing engine. The minimum fuel temperature and the center tank is empty, displayed with yellow crosses. Also the DC coolant for the APU. We have the APU here. We can use the pressurizer now. The green indicates that. We have the left engine, right engine pressurizer system. The hydraulic also. The air conditioning, cabin pressurization. So if I move the thrust levers forward, you'll see the pressure from the engines, the bleed air, the pressurizer increase from here over here, the duct pressure. You can see the stages, the fifth and the ninth stage of the outflow valves, the left engine, right engine, the isolation valves, the flight controls here. We can extend the speed brakes, we can move the flight controls around. You'll see the flight controls surfaces work, the elevator, horizontal tail, vertical tail, and the stabilizer trim. So this is some of the systems. You can see here, this is working. Also the other side. So we have full control here, also the rudder pedal. This is displayed here in this small display of the multifunction display of the Boeing. So we go back into the engine for engine start now. I'm gonna come here in the virtual cockpit. So we have a few more minutes left to go. We need to restart the engine. We have the horizontal tail stabilizer. Also, I forgot to talk to you about the horizontal stabilizer here. This is the trim, the aileron trim also. This for the horizontal tail normal and alternate, and you can see the decrease here of the horizontal tail stabilizer. And we have a failure in the R or the C hydraulic systems. You can disconnect the auto trim function from the autopilot and auto throttle. We also have the fire extinguishers, the fuel control of the engines, and the rudder and the aileron trim here. A couple of things I forgot to mention. So I will turn off the left and the right engine. I'm gonna make an engine auto start or restart process for the engine. So here where we are right now, almost ready to go. We have like 30 more minutes for this flight. So we turn off the engine. You can see the engine slowing down because we turn off the fuel. So you can see here the engine shut down, the N1 decreases. Also the exhaust gas temperature, we have no fuel flow, it's 0 right now. So the N2 also decreases. So we come over here in the overhead panel and we will set off the auto start system. For the left and the right engine, this is gonna advance some pressurizer from the APU, the auxiliary power unit, into the engine's left and right engine starter. You can see the engine shut down message here and the autopilot disconnect in the warnings. The fuel on board here, the flaps. We have the landing gear here, up and down, and now the auto brake system. So when the N2 goes above 20%, you can see, you can monitor in the outside also, the right and the left engine turbofan. So we can start the engine now. We have enough pressurizer. We can advance the fuel into the engine. So left and right engine. Fuel controls, you will see now the N2 and the fuel flow from 0. We will get higher. So we have the necessary spinning to the engine. Now we can set only the takeoff stuff, like the flight management computer. So we have a few more minutes, like 20 more minutes for this flight. So go in the menu, FMC. We have the model here, the identity of the Boeing 777, the positional initializer, the reference airport, the Lszh. You can set the inertial GPS position, 0 fuel weight and gross weight automatically, the reserve fuel for the flight altitude, the cruise altitude 35,300, and the coast change is 100%, minimum fuel temperature, fast limit, Lszh. From this departure airport to this destination airport, runway 14. So we have the departure Lszh 14, 0 to Alpha, and arrival, departure and arrival. Select departure, arrival, airport, transit, -1 Alpha, activate and execute. So we have the route legs here. We only need to set the flap limit for takeoff and the center of gravity automatically, takeoff reference. We have V1, V rotate, and V takeoff, the takeoff speed here, and the complete route is generated here. So I'm gonna show you later when we move in the runway, so we can disarm the parking brakes and start moving into the runway for takeoff. We use also this steering wheel. So The runway here is empty, we can use it for takeoff. You can see also in the navigation display we have no other traffic. So I activate again the parking brakes. I use the outside view. You can see where we are right now and where we're going. This airplane between this runway and the Zurich airport. So I'm gonna come outside. Only use this controller here. So we advance the thrust levers forward. We have the flat set. We can take off. So disarm the parking brakes and go. We have stabilized the engines. And we have like 18 more minutes left to go. So we hold here the control. V1 to rotate. Start climbing. Rotate. And V2, and we have the positive rate of climb. So we retract the landing gear now. I'm trying to pitch it down a little bit because the aircraft pitches up too much. So we are 2,000 feet above the ground level, 2,400, 500 feet, but we are 4,000 above the sea level. We climb with 8,000 feet per minute. This is our airspeed right now, 230 knots. The flap limit here we're gonna have also, we need to decrease the pitch attitude because we're gonna reach the stall speed here. So we decrease the pitch attitude, we stop the stall speed. We have also the waypoints here, the flight plan of the aircraft. So you can see also the thrust I'm using for the takeoff, 104%. Maximum I told you. So we keep climbing here. Maybe we're gonna start turning, making the turn. We have like 18 more minutes. So we keep turning. Also need to keep stop a little bit. You can see our airspeed is Mach 0.551 as we glide 11,000 feet now. We exceed this flap limit here, the speed for the flaps. So we keep gliding. We're gonna have the airport now very close to us. So you can see as we climb out, we have maybe like 18 more minutes left to this part. So we have nice views here. Very nice views here. With the Boeing 777 we fly with about 650 kilometers an hour. Hope you like this view. Also make that turn now. So we're gonna be overflying the lake now as we keep climbing. Gonna be overflying the lake. And we're gonna come closer to the Germany also. So you can see also the galaxy now. We have a beautiful view of the star sign already of the night sky. So we need to come here, keep climbing a little bit more. So we'll set this waypoint now, the legs. This waypoint is going to be our next waypoint. As we climb 30,000 feet, you can see we climb with 600 kilometers an hour, 250 meters a second. So we need to come straight this waypoint, keep climbing, and we have like 11 more minutes left for this flight approximately. We are 32,600. So you can see the flight director here. We have also the stall warning here. We fly 33,000 feet right now. So maybe we have the chemtrails now. We can see the chemtrails from outside. A beautiful view of the frozen vapors of the Boeing 327 as we climbing and keep hold straight as much as we can. 34,000 feet. Now climbing slower. So this is our spacecraft for tonight, the Boeing 327 300ER. We fly with about 700 kilometers an hour now. This great airspeed for about 270 meters per second, 35,000 feet above Zurich. You can also see we have the Germany in front of us. I'm gonna talk to you later. I'm gonna be overflying the Germany. So here we are. We have to level off. Now I'm gonna go back. We track maybe the Flught now. And also increase the airspeed here for going back into the airport. So we're gonna have a higher airspeed. We can level off here manually in the flight director and change direction for going back. You can see the Bayern Munich area here in front of us. The Bayern Munich as we turn manually and hold level as much as we can. This altitude, it's up a little bit. So I'm gonna show you the Bayern Munich now, this area. So here we overflying the Bayern Munich area very close to the Germany. We're flying the St. Gallen Lake in Switzerland. And we have this magnificent star sign. So we have this nicer view of the Boeing 327. So you can see we're trying to hold level into this altitude as we cross this borderline here. So you can see the Germany this side, the Bayern Munich area as we cross this area, making this turn with 900 kilometers an hour, 300 meters a second. So we need to come back level off a little bit. And we have like 10 more minutes left for this flight. So this is good. We can make it to the airport. Maybe use the autopilot now. Hold the Hatsios, so now we have the autopilot on. You can see the AP on. I turn on the autopilot and we can fly the airplane automatically. So I'm gonna set the next waypoint. We have like 10 more minutes left for this flight, approximately. So the legs here is fly direct to this and set the approach reference. The landing airspeed here. With this weight and this runway. So you can see now we're flying straight into the airport. Now we fly with the autopilot. So this is our spacecraft for tonight, the Boeing 737 300ER. We have this magnificent view of the night sky now. So we have like 8 more minutes left. So you can see the auto-thrust system. So we have a few more minutes. We fly with Mach 0.78, 35,000 feet. We have to start descending now to the destination. So we're gonna use descend to a lower altitude now. And hit the flight level change and decrease the airspeed a little bit to a better approach airspeed. So this is gonna activate the system for the descent. As we descend with 900 kilometers an hour or 300 meters per second. As you can see here, coming closer, we have like we have 5 more minutes left for this flight. So we have the autopilot connected. Here's the idle thrust now, our signal. As you can see, we have the thrust idle and an overview of the cockpit before landing. And also the outside, we can see the runways now. We're coming closer into the runways. We cross 18,000 feet right now. And we fly very closer into the airport. So we have like maybe 4 more minutes for this flight. I need to activate also the approach and also deactivate the autopilot and use the landing gear. So I'm gonna slow down the airplane, the airspeed. As we keep descending. And use some Flught, I believe, as we keep descending. $11,000 feet. So we go now closer. We deactivate the warning. Fly manually. 9,000 feet. 9,000 feet. We have a few more minutes. So we have maybe like 3 more minutes left for this simulation. So we can go down for the Lszh approach. You can see that we approach the runways here for landing as we look the outside view. So maybe 3 more minutes. So we have the Lszh localizer. We're gonna cross here this point as we descend. So we have the Lszh localizer here. So you can see here we have the vertical glide slope and the horizontal flight path. We are 2500. We fly with 179 knots and we descend towards the runway over here. Maybe we have like 1 more minute left for this fly as we fly manually. We keep descending. We advance the thrust levers for the approach. We need to have some more thrust and fly manually. Also use the rudder pedals and the yoke, as I told you, the yoke of the 777 to control, to steer the airplane while using the thrust levers here and having visual and Lszh localizer. Decrease the thrust now and increase the descent rate a little bit. So here we are. 10. We just touched down, parking brakes and full reverse thrust. Here we made it to the runway. Very beautiful landing. Trying to steer the airplane also with the tiller and the rudder pedals. So we just made it. Very nice landing here. Runway 14. This is the International Airport. You see some other aircraft flying around us. So you can see here we have the nose wheel of the airplane. You can see there is no breakages, no broken tires, and no broken metal parts. It's everything as it should be. And also the landing gear, the left and the right landing gear of the wheels and the tires. And one more time, the nose wheel, you can see how nice it looks like. It's not broken like some other people are doing with their airplane when landing. Also from this view, so we can take off again one more time and fly one more time this airplane.